Okay, up to now we have learned about up counter and down counter, where up counter is counts upwards direction, down counter counts downwards direction. Right now we are emphasizing on a particular type of counter which is called universal counter. Universal counter means it can count either in up direction or in down direction. That means for each cases we need a particular flip-flop to design a counter, whether it can be 3-bit or 4-bit. Depending upon the bit we are choosing the number of flip-flops, right? So if we are considering a 3-bit up or down counter, or we can say it as universal counter, and we are discussing about the repeal one, that means the asynchronous one. Okay, so we are discussing about the 3-bit asynchronous universal counter, which can be able to count either in upwards direction and in downwards direction. So taking the advantage of this flip-flop, see, suppose if this is 3-bit counter, so we require 3 flip-flops. This is number 1, this is number 2, and this is number 3. And for the each time this flip-flop produces the complementary output QA and QA bar in every cases. So taking the advantage of these two outputs, complemented outputs, we design up down counter or universal counter. Okay, for this case we required a particular control signal which is termed as M. We are taking M as considered a controlled signal. When M having the value of 0, let us consider it will count in upward direction. Okay, and then this QA or Q is connected as the clock to the next flip-flop. Okay, and when M is having the value of 1, it will count the down counter, and then Q bar will connect as the clock of the to the next flip-flop. Okay, that means whenever we are need to design up counter, then QA is going to the clock signal, and when we need to down count, then QA bar will be acting as the clock input signal. For each cases, here it is QB bar for down, and QC for up one, and QC bar for down one. Okay, now we are to achieve the goal, we are required this M control signal. Okay, this M control signal. Now we have to design a particular combinational circuit here in the case of output and the input port of the each flip-flops. Okay, so now we have to make the combinational circuit using this control input M. Okay, now we are taking the truth table for this signal. So M is your input, Q is your one input, and Q bar is your another input, right? Because Q is the output of the previous flip-flop, and Q bar also is the output of the previous flip-flop, right? So basically if we consider the circuit, so this is a combinational circuit, combinational logic circuit, where we are taking a control signal as M, and we are taking two inputs Q and Q bar, and these inputs are the output of the previous flip-flop. Okay, and this is the output Y. This Y is connected to the clock input of the next flip-flop, right? So now we have to design this combinational logic circuit. For that we require this truth table. Okay, now so this is M, Q, Q bar. We are writing down the combination 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and finally 1 1 1. Now you see we are dividing this control input as 0 and 1. So we can say up to this combination it will count up, and up to this combination it will count down, right? Because in these 4 cases the M is equal to 0, so it will count up. Okay, so for that particular case Q is connected to clock, so this output will be the value of this Q inputs. So this will be 0, 0, 1 and 1. Similarly, when m is equal to 1, this Q bar is connected to the clock. That means Y is now focusing the Q bar. Okay, now the output of the Q will be 0, 1, 0, 1. Okay. Now for this we have to construct the circuit for Y. So to take the Y, we are making the K map, 18 cell. For this Y output, we are making the 18 cell K map, and let us put down the value 0, 0, 1, 1, 0, 1, 0, 1. So this is one group and this is one group. So M, Q, Q bar, for this combination 0, 1, 1 and 0, 1, 0. So this is M bar Q, and for this is 1, this is 1, this is 2. For 2, M Q, Q bar 1, 0, 1 and 1, 1, 1. So this is M Q bar. So this Y output is equal to M bar Q plus M Q bar. Okay, now taking this equation, we are now making the circuit. Okay, now we have taken these two input M and M bar, right? So each time this Q, Y is nothing but QA and QB and QC. So we are taking M bar and Q. That means M bar and Q, making the AND gate, and M Q bar. That means this is Q bar and this is M. Okay. So this is the clock signal for this gate. Okay, right? This is one output QA. Similarly, in same manner, M okay. So this is your okay. Now this is the circuit. QA, QB and QC is your output, and each time this combinational, using this logic, the combinational circuit is acting as the clock of the next flip-flop. Now see, when M is equal to, say suppose M is equal to 0, that means this is equal to 0 and this is equal to 0, and for that particular time this is also 1, 1. So when 1 is here, that means this AND gate, right? This AND gate, these two AND gate, as this is 0, it will close. So it will be QA, QB, right? So when this output is selected, it is considered as the up counter, so it will count the up. And when M is equal to 1, at that time what will happen, this will become now 0, this is 1, this is 0 and this is 1. So at that particular time what will happen, this 2 AND gate is now 0, this 2 AND gate is now 0. So this 2 AND gate is now going to operate. So in the lowermost branch means it will count in downwards direction. So like the same way it will counting from, same counter will count from up and for down. It is a very important question for your examination. In your examination, one question has come that consider a control signal M, and when M is equal to 0 and M is equal to 1, it will count from up direction and down direction. মানে একই কথাটাকেই ঘুরিয়ে এসেছিল. This is the answer for universal counter. Okay, now in the previous video I have forgot to make the states. See, whenever any counter is changing its state from 0, 0 to 0, 1, it is basically then 1, 0 and then 1, 1. Say suppose it is counting from 0 to 3, then this each 0001 10 and 11 is considered as state. Okay, this is called the state. এটা আরো ক্লিয়ার হবে যখন we are going to discuss about the counter design, then it will be make more clearer for you. Okay, so up to up and down counter, that means universal counter. This is the example for ripple universal counter. So like the same way you can also construct the ripple universal counter for synchronous counter as well. There simple একই রকম হবে, শুধু ক্লক সিগন্যালটা চেঞ্জ হবে। ওকে, ক্লক উইল বি কন্ট্রোলড, 2 types of clock.